But this is not your final milestone demo, right? This is your second milestone.
Second milestone.
Okay.
Is it? Okay.
Yeah, just send a tweet in case you want to retweet. Maybe we get a couple more people to join, and then we can start maybe in like 2 or 3 minutes.
Okay. Uh, hold. Let me check. Uh,
Okay. So you want to demo both the second and the final milestone in one go, right?
yeah, I think we have pretty much uh, have a working canister right now.
Mm-hmm.
It's already in production. So yes.
Okay. Yeah, so one thing you have to keep in mind is that you have to fill out the final milestone form. I think we haven't sent it to you yet.
Yes, I think, yeah, we tried to find it, but could not find it previously. Yeah, I think you can send uh, the form, so maybe later we can fill it up.
Yeah. Yeah, I just sent you the form on Submittable, so please make sure you fill that one out after we had our review here, because
Yes.
otherwise we cannot distribute the grant.
Oh,
So
yes.
it's crucial that you fill that out.
Oh, yes. We will do.
Okay. So
So I think we can start now.
yeah, go ahead.
Okay.
Stage is yours.
Okay. Thank you.
Maybe
So
I give you a quick intro for context. So for today's office hour, we have Jagat or Yagat, I don't know how to pronounce it, present their second and their final milestone. And grantees have the choice to do this either asynchronous by submitting a form, or synchronously by having a call with us, or synchronously and in public, which is of course our favorite way of doing things, by joining our dev office hours and then giving an overview of their project to other people in the ecosystem as well. And this is what Stephen does today. And yeah, now go ahead, please. Thanks.
thank you. Okay. Hi, everyone. I'm Steven, and I'm here to represent Jagat and my team from Jakarta, Indonesia. So, the purpose of this presentation is to demo uh, the canister and our wallet for community who might want to understand our repo and the use cases. Okay, so uh, our we name the canister ICP account, uh, ICP sub account indexer. The objective, uh, the goal for this canister is to provide the users, the community, to be able to make ICP top-ups seamlessly, and for organizations to manage these top-ups easily through the methods that we provide. So there were several challenges that we face for top-up operations. So, for example, we could track each and every sub account for new transactions. But imagine if we have 10,000 accounts under a single principal. We may need to check every minute, or every few seconds for incoming transfers. This means we would have to make 10,000 API calls. So this becomes uh, unsustainable, becomes quite expensive, and does not scale. So that's challenge number one. And and then we try another approach. If we could track each and every block created with transactions that have destinations matching one or some of our sub accounts. This way, we only need to call once every second. Now we would need some kind of service that does this intensive work in the clouds. But this kind of service has its own aspects that need to be maintained, like running costs of the virtual machines, ongoing maintenance, security, access management, etc., etc. So that becomes challenge number two. And the third is the technical challenge. Currently, both Ledger Canister and Index Canister, they do not provide methods that allow uh, sub-account transactions retrieval by its principal. So there's no way to quickly retrieve recent transactions from all different sub-accounts using just one single method call, which leads to uh, problem number one, the scaling challenge. So uh, we solve this. Uh, so our canister solves the scaling problem. Uh, we check each new block for transactions. Our canister does that, so it also solves infrastructure problem. So all the work is offloaded into the canister, and it's currently the cost to run the canister is about 10 US dollar per month in terms of cycles usage. Uh, so the solution comes in the form of canister methods that we created. So we have several methods. To name a few, add sub account allow us to create new account identifier. List transactions. List transactions allow the caller to get most recent transactions of sub accounts under custodian principle. And sweep uh, allows forwarding of deposited ICP into the sub accounts into custodian pool account. And we have many other methods that solve previous challenges. Okay, so I am going to uh, live demo. So this is our app, Jagat Wallet app. Uh, so I'm going to show top up using ICP. Okay, so I'm going to top up one ICP. So the app calculates the conversion rate to local currency, which is IDR, Indonesian rupiah. which is tokenized in our wallet, and then get opposite address will call the add sub account method to generate the this address, the sub account address. Okay, so we can copy this, and then uh, I'm going to uh, make the top up using NNS. It's a ICP browser wallet. Okay, so I am going to top up one ICP to the address that that we get here. Address, so let me check, should be 11F62339. Yeah, so okay, one ICP. Okay, it is sending. So it just detected the top up as in progress. So maybe we'll wait for a bit. Oh, okay. Okay. It should. Okay. Now, okay, I think this will clear it up later. So our backend actually query the canister for list of transactions, list of recent transactions, and when it's successful, it record everything in the database for subsequent processes. We can now check using DFX CLI. Let me check. Wait.
Try refreshing one more time.
Oh, sorry. Refreshing. Oh.
The app.
Oh, okay. Yeah, I think still. Let me show you how to. Okay. Okay, it's completed now. Okay. Next, I am going to check the custodian balance. I see. So right now it's 0 ICP, but I'm going to sweep, which is the forwarding operation from the canister to the custodian balance, custodian wallet. So I am going to run this method, sweep.
So what does sweep do under the hood? It takes the JIDR, converts it to ICP, and then sends it to the owner of the JIDR on the ICP ledger, or what's happening?
It's transferring the ICP in the sub account, the sub account that receive the ICP. So it first, yeah.
I thought that the ICP, upon being received in the wallet, is being converted into Indonesian rupees.
Yeah.
I thought that you kind of like basically sell ICP for the digital version of this Indonesian rupee. But is that not the case? So you keep the ICP and you just claim that you converted at a stable rate at this point in time into a digital version of the Indian rupee,
Yes.
or how does it work?
Yes.
Yeah.
Precisely. Yes.
Okay,
So. Mm,
so just in theory, so if I mean, this is kind of like a stable coin, right? Because like, I mean, Indian rupee, I guess, is tied to the price of one
yes.
fiat Indian rupee,
Yes.
Indonesian rupee.
Yes.
But
Correct.
at the same time, if you do not convert the ICP into Indonesian rupees, then what happens if the ICP price like decreases a lot? So, for example, I send $100 of or 100 Indonesian rupees of ICP to my wallet, then I get a credit of 100 Indonesian rupees, right? But then the
Yes.
ICP price decreases by, I don't know, 50%. So they are now only worth 50 Indonesian rupees, but in my account I still have 100. Isn't that
Yes.
a
Yes.
problem?
Yes. Correct. It is a problem, but currently it's the risk that uh, we are able to sustain, and we try to uh, exchange as quickly as possible. We try to swap the ICP to Indonesian rupiah as soon as possible. But currently, uh, our finance officer is
So,
doing that through the DFX CLI currently.
uh-huh.
Just a little interjection here from our side. Yeah, so there's some risk here, but it's not absorbed by the stablecoin. So there's actual IDR bank balance at all times, covering all JIDR assets. So
Oh,
the reason why we don't clear right away is because all these small transactions are expensive to clear individually. So we just group them together, and we make sure that any kind of risk that outgrows our risk limits is hedged out.
got it. So you credit less Indian rupees than what the ICP would have been worth at the time they were sent, right? So I sent $100 and then I received like 99 or something to make up for any downside trends until you are sweeping them or clearing them.
Yeah, we do have a margin built in there, but that's for all costs, including clearing.
Mhm. Okay, but maybe conceptually, so this sweep call that we've seen here, is this something that basically Jagat calls, or is this something that the user is able to call if they want to convert back into ICP?
It's an internal operation.
Okay, that makes sense.
So
I
at
thought
this
that
point,
this
as soon as
basically
we receive the ICP token, we already issue out the JIDR, and at that point, you have JIDR. If you want to sell JIDR for something else, it's an entirely separate from this system.
Okay. And how do you? I mean, like you said, one JIDR is always backed by one Indonesian rupee. Is there like proof for that, or do you just have to basically like trust the company behind it that you really do convert the ICP into Indonesian rupees and that there's this one-to-one backing?
Yeah, so there's two pathways there actually. One is we have one. This is how we started initially because we didn't have this set up yet. We started by just having a single big bank balance for all issued JIDR. But we're slowly moving that to having specific per user or per customer bank sort of virtual accounts, so that every single user wallet actually has a virtual account wallet with an Indonesian bank, and those balances are going to be in sync. But that's something that we're moving towards as part of the sort of the compliance we're doing with the Indonesian Bank of Indonesia.
Yeah, that's really cool. I mean, it's nice here because you have, I guess at least a pretty good user experience because the transfers in ICP are finalized so quickly that you can, kind of like have a smooth onboarding flow. Have you been thinking about adding other ICRC1 assets to this as well. For example, CK USDC would be an obvious choice, or CKE for CKBTC.
Yeah, so definitely those are avenues we can easily extend this mechanism with. Yeah, not all of them have the same sort of token standard, so there might be some rework on the canister needed. But yeah, these are very simple extensions, I think, for us.
Yeah, actually, they all do support the same token standard. The ICP ledger is a bit different because it supports two standards. So basically, the old ICP ledger standard and then also the new ICRC1 standard. But the CK tokens all support ICRC1 token standard. So if you are able to support one ICRC1 token, you can support all the others as well, because they are all the same. Basically, it's like an ERC20 token in the end.
Yeah, nice. I think we did another project that we did off ramping of CK BTC as well. Maybe Theo, you could chime in on that one if this is something that with this canister works exactly the same as that one.
Yeah, so for one of our other projects in ICP was late 2023. We helped the local mining team, if you're aware of them. They off ramp CKBTC directly to Indonesian rupiah, and the off ramp system is similar to how we have it right here, but the difference is we don't go through the app first. For local mining, we provide them a specific API that they can call. Essentially, if they want to get money to their bank accounts, they have their own UI, and then they just can call our APIs and send money to the address that we gave them, similar to how this works. But we don't use a canister for them. We just listen to a specific principle using an indexer, like a custom indexer that we made. So for the CKBTC and local mining solution, all of it is off-chain. The main difference with the solution that Steven just presented is that the solution that Steven has here is on-chain. So I hope that explains like what we've been doing with ICP and CKBTC.
Yeah, awesome. Thank you.
Okay, so I will continue with the remaining demo. Okay, so as we swapped the ICP balance, I think now we can check if our custodian account balance, it has been updated now. So but it already used up the transfer fee of 0.0001. So when it reach custodian account, it's already subtracted with the transfer fee. So now once in the custodian account, the custodian can send this amount to be exchanged at current rate. Yeah. Okay, so I think I'm going to go back to so the target audience and users. I can give some examples, like for community, we can use this for example for crowdfunding operation. Organization, we can use this for company that maybe want to maintain accounts for their customers. Exchange can really benefit from this, because they can use the canister to maintain ICP as asset for deposit and withdrawal. And application, for example, just now our wallet app is using the canister for top-up detection and management. Yeah. Okay, I think it's time for I give the floor for Q&A. Maybe anyone wants to ask anything? Anyone? Or maybe anyone from the community?
Maybe we can give them some time to think about any
Yes.
potential questions they might have. Usually people on Discord are a little bit shy to chime in.
Okay.
But in the meantime, I have a question. I would be interested if so first of all, this app that you showed, right? Is there any authentication built in? Like, do I sign in with an ICP wallet with internet identity or plug or whatever, or is this like how do I basically how do I authenticate to the application to in the end get access to the JIDR balance that belongs to me? Can you maybe elaborate on that a little bit?
Yes, I think. Do you want to maybe elaborate, Theo or Bartol?
Yeah, maybe I can just give a little bit of context there. Yeah, so what this wallet is a JIDR is an SPL token on Solana. So we built the sort of the stablecoin infrastructure on Solana a couple of years ago, and so basically we're turning any kind of tokens from ETH or ICP into an SPL token. And the wallet itself is a non-custodial wallet for the SPL part. So for ICP, when we receive your ICP, at that point we hold it in our custodial on-chain sort of canister, the one that we just demoed. But we issue the JIDR token to your non-custodial SPL wallet. And we're just doing our sort of accounting on Solana. It's not necessarily that it's something that you have to think about as a user at all. It's just something that is on chain and fairly cheap. So one of the things that we have been noticing recently is that Solana has been having a lot of issues. So it's definitely something that has been plaguing our quality of service, so to speak. So we've had a lot of trouble getting transactions through. So this is definitely something for like the medium term where we're looking at maybe migrating that entirely. But yeah, so the canister that we just presented, the typical users of that canister would be exchanges or other wallets that do some kind of swapping, and that want to get that up and running on ICP quickly. So we just built that for ourselves as something that we found as a missing piece for as a entity that does some kind of swapping. For our users to be able to get a user-specific deposit address. So this thing just generates user-specific deposit addresses, just like you would expect from your exchange account.
Okay, but so you said that so first of all, what is an SPL token? I'm not familiar with the term. Can you maybe shed some light on that?
Yeah, it's just a token standard on Solana.
Oh, okay, yeah, that makes sense.
Yeah, sorry.
Okay, so you said the wallet itself is non-custodial. So how do I authenticate to the wallet, to the app, basically? Like, do I like where's the private key held to access the funds in a non-custodial way?
So
Maybe I missed it, but I didn't see a sign-in flow when the demo started. So I'm just like wondering, like, how do I authenticate to this,
Right.
or like, how do I authenticate or sign transactions with this non-custodial wallet built into the app?
So there's the typical 12 or 24 word sort of access that you can use to recover a wallet on a new device, but on a single device, the private key is held in secure storage on the hardware. So either on the Android key store or the secure chip on your iPhone, and you access it either by using your PIN code or biometrics.
Okay, cool. Yeah, if you were to migrate to the IC for the token that you currently have on Solana, you could use internet identity as well. I mean, the benefit here would be, I guess, that key management is a bit easier and it's not tied to the device, because what you described sounds like if I basically lose my phone, then I'm basically not able to access this anymore. And then if I wanted to add a new device, I would need to kind of copy the seed phrase or enter the seed phrase in a new device, which can be a bit
Correct.
cumbersome for users. And with II, the flow is a bit easier, I would say.
I think the internet identity flows are really, really high UX. It's some of the things that I've noticed. It's quite rare for sort of Web3. It's so easy to create an account, log it in with biometrics, and switch between devices and stuff. So that's something that's really cool, and that's why we are also considering moving all of this over to IC. One of the downsides is that there's a little bit less on transaction record keeping on IC. So
what would you like to see? Or what are you missing? The other way around.
So for our transactions, everything is on chain as a Solana transaction that we kind of don't have control over. So all the transactions are hard coded on chain and staying there forever in history. And on IC, the transactions are a little bit more ephemeral, I think, for performance reasons. But like the ledger doesn't hold much history. So that was one of the things we didn't really have like a clear path to IC yet. And then maybe we just didn't really correct.
So you're right in that the blocks or the raw transactions on the IC are not really accessible, but ledgers usually have their own tiny blockchain that they expose, and it's the same for the ICP ledger and any other ICRC1 ledger. They store all of the transactions since the first transaction to the latest transaction that happened, and they also reference a hash of the previous transaction. So they basically do expose blocks. The difference is that each block in this blockchain basically only consists of one transaction. So it's not like Ethereum or Bitcoin block where you have multiple transactions in a single block, but the block itself is basically just a single transaction. But you do have access to all of the transactions of the ICP ledger or CKBTC ledger or CKETH ledger, and they are all stored and you can verify them as well. So
and this would be outside of our control, so completely immutable.
Yes, yeah, they are completely immutable. You cannot,
And when we would make our own ICRC1 token.
I can maybe send you a link real quick to the implementation. So you basically deploy a suite of canisters if you deploy an ICRC1 ledger. So you deploy, usually, you don't have to be compliant with the standard, but usually you deploy the ICRC1 ledger itself together with an archive canister that basically stores the blocks, all of the transactions, because as you know, if you have a lot of transactions, they consume a lot of state to store. So potentially the ledger could run out of storage trying to store all of the transactions for the next 100 years. So that is why there are also archive canisters. So from time to time, the ledger canister pushes, let's say, the recent transactions that it hasn't yet pushed to the archive canister, and there they are persisted long term. And the archive canister itself, it realizes, oh, I'm close to my storage limit. It can spin up a new canister where then the next batch of transactions is stored to. And that way you have the ledger canister with a number of archive canisters that together form the entire history of all of the transactions that ever happened. And to make on-chain interaction with this history a bit easier, there's also an index canister, and that, as the name already suggests, indexes over the transactions or blocks in the archive canisters. For example, to make it easier to get, for example, all of the transactions belonging to a certain account, right? Because otherwise you would need to iterate over all of the archive canisters and all of the transactions within the archive canisters, which is pretty computationally intense. So that's why we have this convenience canister, this index canister that takes this heavy load away from you. I'm going to send you
just one question I have is about the immutability. So when we deploy these canisters, we basically can change whatever we want in the code of them, right? So they are under our control in a way. Is there some way, like what we're used to doing on EVM and Solana, is use an existing on-chain canister that spins up these canisters for us? So it's kind of out of our control how this is defined. Or in some way, is there some way we could provide proof that we're using the specific code for existing ledger canister?
Yeah, sure. So usually how this works is that you take your high-level programming language, in the case of the ICRC1 ledger canister, that is Rust. So the canister and the archive canister and the index canister, they're all written in Rust. And then you compile this high-level programming language into a WASM module, because this is what you install on the internet computer in the end, right? And when building the Rust code into a WASM module, you can use a pipeline or a setup that allows you to get reproducible builds. So that basically means that you provide an environment where if you build the same code twice, the bytes that are coming out of that compilation are exactly the same. And that helps you because that way you can create a hash of the WASM module, right? And this hash is what is being exposed by the internet computer, by the system itself. So for every canister on the internet computer, you can query the network for the hash of the WASM module. So what you would do is you would take the ICRC1 repository at a certain point in time, at a certain commit, and you say, this is the ICRC1 ledger that I deploy for my project. You build it in an environment that allows reproducible builds. So other people can build this as well, and they arrive at the same bytes, basically at the same WASM module. And if you would hash this WASM module and they would hash this WASM module, the outcome would be the same. So they can compare the hash that they have locally with the source code that you said you are going to deploy with the on-chain WASM module hash that is exposed by the system. And if they look at your code for the ICRC1 ledger and it's legit, they build it, they get a WASM module, they hash it, they get a hash, and then they compare that hash with the actual WASM module that you guys deployed on the internet computer, and those hashes are the same. They can be certain that the code that they've seen in the GitHub repository is exactly the same code that has been deployed in the canister, and that there are no backdoors or no bugs or nothing bad going on.
Okay,
you could also there's also for SNSs, there's also basically a canister that goes a bit into the direction what you mentioned. So is there like a factory that allows me to deploy ICRC1 ledgers that are basically trusted? So I can make sure that they are that they are not containing any malicious code. And so there's the SNS WASM, I think it's actually called SNS W canister, and that kind of like holds a number of blessed ICRC1 implementations. So basically, it holds WASM modules that if you create a new SNS, are going to be deployed on behalf of the SNS to the internet computer. And that way people can be sure that there's nothing weird going on or nothing bad going on. Yeah, I hope that made sense. If not, please feel free to ask questions and try to clarify.
Definitely have something to explore about the blast canisters, but like the reproducible builds is perfectly answers the question. Yeah, so there's a clear way for us to basically provide trust to our community regarding how the token is issued.
Yeah, exactly. And of course, you would black hole the canister after deployment. That means that you remove all controllers and basically remove the ability to upgrade the canister code after you deployed it. But I think it's the same for Solana, right? I think programs that you deploy on Solana are also mutables or upgradable. And there's the same pattern on Ethereum. Even though a smart contract itself is immutable, people tend to deploy proxy contracts that through which you interact with the implementation of the code or of the protocol or dApp or whatever. And usually those proxy contracts can be, or the addresses that are saved within those proxy contracts can be altered as well by like a multi-sig or something like that. And on the IC, we solved this by having like a DAO around it where you have to stake tokens and there are proposals and you need to vote on the proposal. And only if a majority of the token holder agrees that a canister should be upgraded, it then is upgraded. So it's a more very sophisticated multi-sig, you could say.
I think the key distinction here is that what we used for creating the token is a little bit different on Solana than on the internet computer, because the creation of a token just uses an on-chain program that is managed by basically by the sort of community anyway. So it's like the SPL program is what you call a method on to create a token. So we don't have any control over that contract whatsoever. In the case of launching a token under ICRC1, it gives us a bit more control. That's kind of that control I want to exclude. I want to be able to prove to our community that we don't have that control, because
yeah, then that would be a good way of doing things. I can send you some docs around the SNS, and there should also be some info on the SNSW canister, which is basically the SNS WASM canister. Let's see. Yeah, I just realized there's not too much documentation around this, but this sheds some light. And you can also find some docs here. And let's see. Yeah, I think that should be sufficient. Okay, cool. So maybe if there are community questions, maybe feel free to unmute yourself and just ask away.
Yes, anyone have questions?
I have another one. When you are deploying or sending the ICP to the sub account that has been generated, do you generate one sub account per deposit, or do you keep the same sub account for the same user, basically? Like, are you like increasing a nonce for each deposit, or I mean that's probably hard to maintained globally across all apps. So I assume you somehow convert some identifier, maybe the address of the
Yes,
of
correct.
the wallet or something.
Correct. So we keep track of we record the nonce in the stable memory, but for we don't generate new uh, sub account for every deposit. So only for every user account. So every individual user account is tied to one sub account ID.
Mm-hmm. And how do you derive this sub account? Like, what can you maybe explain a little bit how you end up with this 32 bytes? Like, is there like a conversion step? Is there more information encoded in the sub account, or is it just like
Oh,
is the address or public key that you have from the wallet 32 bytes already, and you just use that?
we use the nonce for each user creating a new ICP address. So we increment the nonce and we use that specific nonce. We use that as the sub account part argument to generate the sub account ID. So whenever we upgrade the canister, we would use this nonce to recreate uh, all the sub accounts in and put them in the local thread in the volatile memory. So uh, we don't keep the sub account IDs in the stable memory, only the nonce. And whenever we upgrade the canister, we re basically we regenerate the sub account IDs and put them in the volatile memory.
Mm-hmm.
So yeah, this I hope that explained.
And just to add a little bit of info from like the user point of view, so we have a unique deposit address for each of our users that doesn't change. So a user could, for example, in their plug wallet, put that in their address book and then just send to the address, and we will handle the top up for them.
Mm-hmm.
This is
Cool.
typically an exchange feature that you will have on like the centralized exchanges, that you have a network specific network user deposit address, and then that one
Yeah.
doesn't change. You can just store it in their wallets. And this
Yeah.
canister really is trying to make that mechanism easy.
Okay. All right. Maybe regarding the flow that you currently have. So now you have this basically transfer notify flow, right? People transfer ICP to a sub account under your control, or that you have custody of, and then you have this canister that scans all of the blocks on the ICP ledger, and to my understanding, at least, as soon as it sees a transaction belonging to its own sub accounts, it kind of like notifies or transfers, and yeah, it notifies the backend that you have. So maybe two questions there. Like, how do you know which sub account belongs to you? Like, how do you know that you control a certain sub account on the ledger? Isn't it like impossible to know, because they are basically like I think they are actually a hash of the principal and this 32-byte array that you pass. So how can you go back to the principal and know, like, yeah, I control this, those funds are directed to me? Or is there another process that's happening at the same time that kind of like notifies you that a
The
certain sub account has been
I
targeted?
So yeah, it's a bit tricky and technical. So indeed, but I think I have to dig into the code to remember this, but yes. So we basically record the. I think we not only the. Okay, we don't record the sub account ID itself, but we record the the sub the sub account part argument. We do have that as the basis to reconstruct uh, the hash map into which the all the transactions we scan in the block, we compare the two two uh, two account identifier, and we are able to match them together.
Yeah, so one of the key insights here is we have our principal, so we know what principal we're working with, and then we store a nonce value, which you can just think of as an integer. And let's say that integer is starts at 0, then you add a sub account, we increment it to 1, and then you add another 9 sub accounts, we increment it to 10. So with this integer, we know that we need to generate 10 sub accounts following a fixed format, using the principal plus 0, principal plus 1, principal plus 2. Each of those will lead to one sub account. And in our database, we have a record that keeps track of that particular sub account of the user and the public address for the wallet that the user has this sub account linked to.
Mm-hmm. Did you think of other flows, like maybe a proof and transfer from flow, or is this not feasible or
Yes.
suitable for
So
you?
this flow is the trade-off was that we have very little storage requirements for a large number of sub accounts, as well as we have a way to quickly generate all of the sub accounts that we can check against against these ledger transactions. So we create this list of sub accounts so we can do a quick include lookup on using that B tree. So that's just for like a quick index search
Mm-hmm.
without having to store all of the sub accounts on persistent memory.
Cool.
And there's other flows we could think of, but this is kind of the one we settled on as the kind of the right balance between storage usage, compute usage, because we're scanning a lot of transactions, right? We're scanning all of the transactions that happen on ICP, and they might not be there might not be that many right now, but there might be a lot more in the future. So we wanted to, make that check as efficient as possible.
Yeah, that makes sense. Do you have an architecture overview or like documentation that explains the working of this transfer logic and scanning logic? That
We have sequence diagrams. Everything is spec'd out fully. We'll definitely share all of that.
Awesome. Love to hear that. Can you maybe share them?
Uh,
Um,
right now, yes.
but let's,
Yes, we. Sorry. Uh,
yeah, go ahead, Stephen. Just if you want to share one of the slab documents, let me just check if there's no like security
oh,
related thing.
okay, but okay. I think we will have to look it up in the. This is the overview. The architecture. The interaction between our wallet and the canister, but the canister itself, I think I will have to check again. I mean, can we share that maybe? Yeah, let me check.
I'm looking as well in our knowledge base.
Okay. I believe uh, we separately uh, we separately put the design, the specs for each method, I think. So there's not one single design for everything. only one method by one method?
That's okay. Maybe we can just look at the one that checks where we check the transactions.
Oh, okay.
There's one for the sub-account derivation mechanism. Is that public already?
Oh,
Yeah, let me
I
share that here. So this one is how we derive the sub-accounts.
okay. I'll put it down. Yeah. Sorry, do you have that? Oh, in the chat. Oh yeah. Okay. So we shared that. Let me check. I think this is the mechanism for sub-account derivation. But as for the deposit, the top up tracking, I'm not sure. I mean, I think this is just the sub-account derivation mechanism.
Oh, we haven't put these from the Trello into the knowledge base yet. That's
Oh,
what's
okay.
happening here.
Oh, okay. Yes. So I think can we follow up on
Yeah.
that?
Also.
We'll
Okay.
send that across. Our process has these specifications starting out in Trello. They're supposed to be in here, but we haven't migrated them yet. We can't share as easily on Trello. That's why.
Okay. Yeah.
No worries.
Okay.
Okay, cool. I mean, we are already over time, so let me quickly scan over the deliverables and make sure that we've seen everything. Give me maybe a minute.
Okay.
Can you share the GitHub repository from what you've built?
Yes, yes. I think it's set to public. Let me share that.
Yeah, we made it public from pretty much the start.
Okay. Yes, I just shared it in the chat.
Awesome. Okay. Yeah, I think this looks good.
I think
Yeah,
we
you-
should rename some of these things. Just the ICP sub-account prototype part should.
Yes.
Go.
Yeah.
So our first milestone was to build a prototype, and somehow that's how our GitHub repo ended up being called. So we need to change that to a little bit of a catchier name.
Oh, okay. Yes, we will do.
Yeah.
Yes. So kind of our hope is that others will find this repo useful. So others that are maybe integrating like user deposits for ICP as an exchange. So just as a mental model, not a particular, but an entity like Coinbase might want to use this canister to make it easier to make these user-specific deposit addresses. So if that's something, because we also saw on the ICP fora others looking at this problem, and I think the typical responses from you guys was that you can easily just do this. You can just make the code to do some kind of variant of what we built here, and we're kind of hoping that this can be over time the variant that just makes it a little bit easier for others to quickly onboard ICP as a as a token that they can receive deposits in.
Yeah, true. Yeah, it would be nice maybe if you, when renaming the repository and removing the prototype suffix, that you could also maybe add a README to it, because right now it seems like it's basically the default README that you get when you generate a new project with defects. And it's always nice to have like more context and links to the sequence diagrams and links to the article that you shared earlier about your sub account logic, and that always helps people kind of like understanding what's going on and how to
We're going to do all of that. We're going to make this a nicely polished place for people to find references to all of these things.
Awesome. Very nice. Okay, then thank you for taking the time. I appreciate it. It was very insightful. I think you did a very good job. Looking forward to seeing people in Indonesia paying their goods basically through ICP. And yeah, thanks for taking the time to present here today and to open yourselves up to questions to the community as well. And with that, I would end today's office hour. I will mark your milestone. The second and the final one is complete, but I again repeat that you need to fill out this final demo form, because otherwise you won't be able to receive your distribution. So I would urge you to maybe do it just now so you don't forget it, and then you're all set.
Thank you.
Yeah, we're gonna get on that right away. And if any of you guys find yourselves in Bali and want to buy coconuts and you only have ICP, just download our app, and then we can help you turn ICP into coconuts.
That's nice. All right. Bye, everyone. Have a great day.
Thank you, everyone. Thank you.
Bye.
Bye.